Good day, friends. Compressed air is the lungs of your workflow. We'll look at how to choose the right compressor in this video. The most common types of compressors are screw and piston. Piston ones are divided into belt-driven and coaxial. Coaxial ones, in turn, are divided into oil and oil-free. We're going to examine each of these compressors today. And we'll start with the oil-free ones. As the name suggests, the air is supplied without any oil impurities. This is essential for areas where air quality has a direct impact on the quality of the work being performed. Smaller models are designed for personal use in a home garage or workshop, such as basic tire inflation and simple blowing tasks. Higher performance units, which are more demanding on the electrical grid, are intended for larger and more demanding projects. Key benefits of these oil-free compressors include low noise levels, minimal vibration, and the fact that there is absolutely no oil in the air. They also offer very straightforward maintenance and easy starting even in cold weather conditions. Models with 3 or more electric motors feature a control unit to shut off a motor if needed. Please remember that when filling the tank, the total load falls on the remaining active heads. Speaking of easy maintenance, you simply need to check the filters, tighten the threaded joints, blow out the motor, and drain the condensate. That's all you need to do. Even with all these advantages, this form factor has one significant and major drawback: extremely inadequate dust protection. And I'll show you right now. We just got an industrial electric motor in for repair from a site with a lot of dust. When it first arrived at our facility, it was completely blanketed in a thick layer of fine dust, and unfortunately the motor failed, specifically because of it. Now I'll show you the consequences and results of not following the operating rules found in the manufacturer's technical instruction manual. Of course, since we diagnosed this engine, we've already blown the dust out. Now we're showing you the aftermath, but we're currently working hard on these motors to make them dust-proof. Here it is, also covered in a thick layer of dust, of course, but the consequences, I will show them to you right now, as they are clearly visible here. The cylinder liner and the piston ring are both heavily scuffed, which eventually causes the electric motor to fail completely. So that was a clear example of how a compressor is operated incorrectly. But if your specific facility meets all the necessary operating requirements, then you can safely go ahead and start using this equipment. From here, we're moving on to the next type of compressor. This is the coaxial oil-lubricated one. The oil-lubricated coaxial compressor, a classic design familiar to everyone. It's a compressor head connected directly to the electric motor. Among the significant advantages of this type of compressor are quite respectable performance and a straightforward and easy-to-understand design. Among the notable disadvantages you may encounter are the increased levels of noise and vibration during operation. Essential maintenance rules include consistently monitoring the oil level as well as ensuring its timely replacement at the correct intervals. Please note that all of our compressors come with helpful tips on exactly when to change the oil, when to drain the accumulated condensate, what specific actions to take, what you should not do, and how to properly preserve your equipment for the long term. Here you see a nameplate indicating it passed pressure testing at the factory. It's on all the receivers of our brand. Here, for example, is a sticker about passing maintenance. It specifies the time intervals and what needs to be done. If you need a simple, versatile, and affordable compressor for pneumatic tools that don't require any special features, an oil coaxial compressor is a perfect choice for your needs. Moving on to a more serious segment. These are belt-driven piston compressors. And here we have plenty of options. in terms of receiver volume, horizontal or vertical variety, compressor head design, and electric motors for 220 and 380 volts. These compressors are often chosen for mechanical shops, tire shops, body repair, and workshops where pneumatic tools are used actively and regularly. If you have a mechanical tire or body shop with a regular workload, a belt-driven piston compressor is often the optimal solution in terms of price, lifespan, and performance. Separately, I'd like to talk about this line of compressors. Here we have a phase control relay. This system is engineered and designed so that if there's a phase imbalance that exceeds or falls below the normal range or a total phase loss, it protects the motor from burning out. It immediately cuts off the power supply and prevents the compressor from running until the electrical conditions have returned to their normal state. Now we'll show you how the phase control relay works. We have 3 balanced phases. We apply voltage, the compressor is running. At a certain point, my colleague will disconnect the phase and the phase control relay will trip. Watch. Because we are missing one of the phases, the relay signals an error. The motor doesn't overheat, it's saved. Now my colleague will turn on the phase, the relay will detect the voltage and restart the compressor. Similarly, the relay will signal an error if the phases are incorrectly mixed up. Until the phase imbalance is corrected, the relay prevents the compressor from running. As soon as the phase returns to normal, the relay detects the voltage equalization and starts the motor. And it also shows us this with a green LED. When we introduced this relay into our lines, we thought about how to protect our customers from a sudden and very unpleasant compressor failure, and thus, the loss of the ability to work. According to the maintenance schedule, things are a bit more serious. Filter replacement, checking the tightness of threaded connections, belt condition monitoring, belt replacement, checking pulley alignment, oil monitoring, timely oil changes, and constant condensate drainage. To make sure you don't get lost in all this, we've made a sticker for you, but in return you get a whole new level of capabilities. And now we're moving into the serious part of the show. This is for those who need air constantly, in large quantities, and stably. Screw compressors. While piston compressors are designed for intermittent work, screw compressors are built for continuous load. A screw compressor is especially relevant if you have a large service center. Multiple stations operating simultaneously, a constant demand for air, where stability, service life, and noise comfort are important. A stable operating pressure of 10 bar is the industrial standard that allows for the use of a wide range of professional pneumatic tools without power loss. The controller is the brain of the compressor. It doesn't just manage, it protects your investment. It monitors motor currents with 1% accuracy and temperature with 1 degree precision. If the current exceeds the norm by 1.2 times, the system won't shut down the compressor instantly, but will let it run on a smart overload curve, cutting off only in case of a real threat. This eliminates false alarms. Upon arrival at the warehouse, screw compressors always undergo pre-sale preparation. Our service center staff check the overall operational performance with the receiver filling time, and also recharge the dryer with refrigerant. Changing the factory settings of screw compressors is strictly prohibited. So if there is a need to lower the pressure, it must be done on the airline using a pressure regulator. Maintenance for screw compressors is already quite a serious and critical procedure. It must be monitored: oil, filters, separator. The schedule is specified both on a sticker on the equipment body and in the manual. Also, the onboard computer will definitely remind you of the need for maintenance, both according to the calendar schedule and the accumulated operating hours. So if you need constant air, low noise, high performance, and uncompromising operation, then screw compressors are your professional choice. And now, the most important part begins. Choosing a compressor isn't just a matter of type, it's a matter of the specific task. For detailing and dry cleaning, it's usually logical to look toward oil-free compressors. For painting work, not only performance but also air quality is important. Moisture and oil in the system are especially critical here. For mechanical shops with constant use of impact wrenches and air tools, a belt-driven piston unit is often ideal. For heavy loads, a screw compressor is the better choice. But keep in mind, a screw compressor isn't the kind of gear you can just run for 5 minutes and then turn it off. The air-oil mixture must heat up to a certain temperature to remove all moisture and keep the screw pair at the right operating temperature for the oil film. Otherwise, the significant difference in temperature creates a dew point, causing the formation of internal corrosion, which inevitably leads to premature equipment failure and costly repairs. So if you choose a screw compressor, the calculation logic needs to change. You shouldn't get one with a large amount of extra capacity, but rather one that is designed to run constantly rather than intermittently. For tire shops, it's vital to understand the actual tool consumption. A piston unit might suffice for one bay, but if the volume is high, the logic changes. Now, how do you avoid mistakes with performance? First, you should examine the consumer, not just the compressor, your tools and your equipment. If several tools are running at once, the total air consumption will naturally begin to add up. One very important point to keep in mind is that the rated capacity and the actual output are two very different things, because compressor performance is always measured at the initial air intake stage. So in practice, you should factor in a margin of 20 to 30%. After that, you look at the receiver tank volume. The more intensely you work without brakes, the more important the air reserve becomes. How do you avoid making a mistake? Say there's a large shop, they add up the consumers and buy one big compressor. But that's not the right way. It's better to pick compressors for specific tasks, one for painting, another for mechanical work, and a third for the tire bay. Why is this more cost-effective? It's easier to match a compressor to a specific task. It offers better fault tolerance. If one compressor goes down, the rest of the shop keeps working. So, smart compressor selection isn't just about which one to buy, but how to properly design the shop's air system. Now let's talk about proper compressor installation. Even the most reliable compressor can experience significant failure if it's not operated correctly. The room must be kept completely clean, free of dust, paint overspray, and metal shavings. Good ventilation and a steady air supply are essential. The manual specifies a required distance from walls for a reason. A compressor pulls in massive amounts of air. If you don't provide a good supply, it basically suffocates, just like a person would. Proper power supply. Forget about extension cords and thin wires. Check the manual. The wiring must meet the specifications. A compressor's lifespan depends directly on proper maintenance. The schedule is in the manual, and for your convenience, we've added stickers. Safety regulations. Before starting any maintenance, bleed all the compressed air from the tank and unplug the compressor from the power source. Note that screw compressors use their own specific oil and piston units use theirs. It is strictly prohibited to use oils not specified in the manual. Also, never mix synthetic and mineral oils together under any circumstances. Now, about draining the condensate. The manual lists 2 criteria for draining condensate: time intervals and operating hours. But we understand perfectly well that draining condensate is more of a local factor. Why? Because humidity is different everywhere. You should start by checking the condensate after every ship. Then draw your own logical conclusions about the drainage frequency. Besides this, monitor the oil level and its timely replacement. Check pulley alignment, tighten threaded connections, and replace filters. All this will extend the service life of your equipment. A compressor is a machine, just like your car, and any machine needs periodic maintenance. Also, you shouldn't turn off the compressor just by unplugging it. Turn it off via the control unit, then release the air from the receiver. This prevents the compressor from starting under pressure, that is, under load. And the most important point we want to convey is that buying and installing the cheapest or the most expensive and powerful compressor won't always be the right solution for your needs. If you're not sure which compressor you need, please contact us, and we'll definitely help you with the selection. Alright then friends, I hope this video was helpful and informative today. Follow the link in the description to check out our full range of compressors, and if you have anything at all to add, feel free to share in the comments below. Thank you for watching.